Alright guys, welcome back. This is Angela from the App Brewery, and in this module we're going to be making something really awesome. We're moving upwards in the world and we're going to be building much cooler websites. So in order to teach you about some of the more intermediate / advanced parts of the document object model, or the DOM, I wanted to show you how we can build this drum kit website. So by the end of this module, you would have not only understood how to add event listeners to buttons and keystrokes so that you'll know when the user is tapping on the keyboard or clicking on a particular button on your website, and you can respond to it, but you'll also end up with this awesome website that you can impress all of your friends with. So the way that this works is that we've got a number of keys here that represent different drums in a typical drum set. And when you click on any of these buttons, then you'll get the corresponding sound of the drum. And in addition, you can also use the keys on the keyboard. So now every time I crack a terrible programming joke, I'll be able to give you a drum roll. So I hope you're ready. It's going to be really exciting. Let's get started in the next lesson. Now, in the last lesson, you should have downloaded and unzipped the starting project. So go ahead and open it up inside Chrome and also inside Atom. So currently I've got the index.html, the index.js, and the styles.css open side by side inside Atom. And I want you to have this same configuration so that we can work along with it together. Now, the first thing for you to do is to link up the index.js with our index.html and test it using an alert. So pause the video and go ahead and do that. So as we did before, we always put our scripts right at the end, just before the body closing tag, and we use the script with a source. So the source is of course index.js, and hit save, and then let's just give it a test, as always with a simple alert, just to make sure that everything is linked up properly and it's working. And so now inside our index.html, we've got a link to our style sheet, we've got a script that points to our index.js, and we're ready to begin. Now, at the moment, even though I have all of these buttons on my website, nothing actually happens when I press on them, right? Absolutely nothing happens. Now, in order to start registering the button clicks, I need to add what we call an event listener to it. So the buttons will let me know when a user clicks on it. Now, inside our index.js, let's first create a function that does something when the button gets clicked. So let's call this function handleClick, and it's going to take no inputs, but it will carry out an alert that says, I got clicked. And we basically want our button to trigger this function when it receives a click. So in order to do that, we first have to select our button inside the HTML and add an event listener that listens for when it gets clicked. And when it does, to call this function called handleClick. So first, of course, we'll need to tap into the document, and then we'll query selector for our button. Now, I'm only targeting the first button here, just so that we can see what's going on before we start trying to do this to all the buttons. All right, so now that I've selected my first button, the next step is to add an event listener. And the method for it is pretty much what it sounds like. It's add event listener. Now, if we take a look inside the documentation, as you always should when you're using a new method or a new property, then you can see that the method addEventListener sets up a function to be called whenever the specified event is delivered to the target. So the target in our case is the object that we're calling the method addEventListener on, which in our case is simply just going to be the first button on our web page. And then we're calling the method addEventListener. And this event listener usually has two parameters. The first one is the type, which is a case-sensitive string representing the event type to listen to. And if you click on this link, you can see all of the different event types that you can listen to. But in our case, we're just looking for something really simple, which is simply the click event, which means that the mouse clicked on the button. So let's go ahead and add that click event. And remember, we have to add it as a string. So that's the first parameter done. Now, what about the second parameter? Well, the second parameter is a listener, and this usually is a JavaScript function that's going to be called when that click event gets detected. So in our case, we're going to call our function handle click. So what this line of code does is it finds the first button in our document, which is the W-drum button, and then it adds a event listener to that button so that it listens for clicks that happen on that button. And when it does, it runs the code inside the function handle click. And that should send us an alert saying, I got clicked. So let's try it out. Let's refresh our website. And if you remember, I only added that event listener to the first button. So if we click any of these other buttons, still nothing will happen. But when I click on the first button, then you can see that we've got the message, I got clicked. So that means that this button is listening for every time that the user clicks on it. And we're able to get it to call a method every single time it does get clicked. So this is getting us closer to our goal, right? Now, event listeners are a little bit like when you're going to a party and you're asking your dad to pick you up. You're giving him an event listener by telling him to wait for a message from you that tells him to pick you up. And by doing this, you're essentially adding an event listener to your dad. Now, as the evening moves on and you're getting kind of bored with the party, you decide to message your dad. And when he receives that message, he will carry out a function, namely picking you up, right? That's what dads are for, I guess. So this is exactly the same thing that we're doing with our code. Now, the keen-eyed amongst you might have noticed that the way that we're calling our function is a little bit different from usual. Namely, we normally call our function with a set of parentheses. But in this case, we're not using it. Now, why is that? Well, let's see what happens when we do add the parentheses. So let's save and let's refresh our website. Now, you'll notice that immediately this alert gets called. And this is the problem. What happens is that our code will run and run and run until it hits the script tag, and then it'll go and find the index.js file that we specified in the script tag, and it'll run this line of code. Now, if we had the parentheses here, then this is a straight up method call, and it will call that method straight away when it's adding the event listener. Now, that's not what we want to happen. We don't want this function to trigger as soon as the event listener is added, right? No, we want it to trigger when the click happens. So in that case, instead of calling our function as we would with the parentheses, we're passing in the name of the function as an input. So that means that we're waiting for this click event to happen before we call the handle click function. And this is a bit of a logical jump that you'll have to make in order to understand a lot of things in JavaScript. It's the idea of passing a function as an input so that it can be called at a later time. Now, there's other ways that you'll see this part written out in the wild. The most common way is instead of adding a function name here that calls the function later on, most people will write this code as simply an anonymous function. So anonymous functions look pretty much exactly the same as a normal function, but they're just anonymous. They don't have a name. So this is what it would look like, and we can replace this part of the code with our anonymous function. So now you'll see it does exactly the same thing. Namely, when I click on the button, it goes and carries out the content of that anonymous function. And inside the parentheses of this anonymous function are all the instructions that you want to happen when that button detects the click. All right, so this is going to take a little bit of wrapping your head around, but I really want to challenge you with a small task. And the problem you have to address is at the moment, we're only adding an event listener to our first button. because we're using query selector, which selects the first button in our index.html. Now, I want you to change this code or write some new code so that we're adding an event listener to every single button, so that no matter which button you click on, you'll always get this alert that says, I got clicked. Now, there's a really, really roundabout way of doing this, and there's a better way. And I want you to figure out what is the better way. And as a hint, it shouldn't take you more than 5 lines of code to do this. So pause the video now and see if you can figure out a way of adding the event listener that does exactly the same thing as what we've got here, but to all of the buttons. All right, so how did that go? Well, in order to solve this challenge successfully, you would have to recall that previously in our JavaScript lessons, we learned about loops. And loops are a great way of preventing ourselves from doing really tedious work. Because you might realize that you can say something like query selector all for button, and then you can say for the first button, add event listener, then for the second button, add event listener, and on and on. And there's 7 buttons. So that's a lot of lines of code, which we are not interested in doing, right? So instead, what we can do is we can create a for loop. And remember, for the for loop, we start out with creating a variable I that's equal to 0. And then we specify the upper bound of I, so namely, when should our loop stop? And in this case, we want our loop to loop through 7 times because we have 7 buttons. And we can get that number 7 by simply saying document.querySelectorAll, and we're going to select all of the items that have the tag button. Now, this is a little bit dangerous because say if later on we decide to add another button, say in our footer, like a button that points towards our Twitter or our Facebook or whatever it may be, then this loop is also going to loop through all of those buttons, adding an event listener. So we should really be a little bit more specific with our selector. And if we take a look here, all of our buttons have a class of drum applied to it. So instead of just targeting button elements, we can be more specific and more safe by saying target all of the elements that have a selector of .drum. And remember, the dot specifies that this is going to be a class that we're targeting. So now we're looking through our document, querying for all of the elements that have a class of drum, and then we're going to call .length on it in order to see how many elements we've got that have a class of drum. And that number will help us determine when we should stop looping, because we essentially just want to loop through all of our buttons and add event listeners. So what better way of stopping our loop than figuring out how many buttons we have that has the class drum on it? Now, you can also separate this line out if you wish, and if it makes it clearer to you, by creating a new variable saying number of drum buttons, and you can set it equal to this, and then you can use that inside the for loop by saying start I from 0 and end when I is no longer less than the number of drum buttons. And finally, we're going to increment I by 1 each time. So now inside our for loop, we're going to use this part of our code, right? So we're going to paste that into here and maybe give it a little bit of space from everything else so you can see more clearly what's going on. And in this case, we're looking through our document, we're querying for all of the selectors that have the class drum, and then we're selecting each individual element from this array to add an event listener. So we want to start off with 0, and then the next time the loop runs, it'll be 1, and then it'll be 2. And this is where we put our I. So when this loop starts off, I is going to be equal to 0. So this is going to be equal to 0. So we get our first drum element. And then the next time that this loop runs, I gets incremented by 1. So this I is now equal to 1, and we get the next element, and so on and so forth. So now if we hit save and we refresh our website, then you can see that no matter which button we click on, we're always going to get the alert, I got clicked. So that event listener has been added to all of our buttons by using a for loop. Now, if you find it easier, in this case, you can also use a while loop. So while I is less than the number of drum buttons, or whichever way you found to be most effective. Now, what I didn't want you to do was to write out this code 7 times, changing the I from 0 through to 7. So if you had any problems with this challenge, then I strongly urge you to take a look back at the lessons in the JavaScript module where we went over this concept of loops, and maybe repeat some of the exercises and challenges so that you're fully comfortable with this before we carry on. But once you're ready, we're going to get started playing some sound. So for all of that and more, I'll see you on the next lesson. So now that we've seen how we can add an event listener to our HTML elements in order to listen for when they get clicked, let's drill down and take a deeper look at how this add event listener function works, because it looks a little bit weird and different from the functions that we've seen so far. So over here, I've got the JavaScript Wikipedia page open, and I'm going to use it to show you a couple of things and what happens when we add an event listener. So one of the cool things that you can do in Chrome is you can highlight, say, the title here, and you can right-click, go into Inspect, which brings up the Chrome Developer Tools, and you see that the element that's currently selected, so the H1, can be accessed in the console using this $0 variable. So if we head into the console and we type $0 and hit enter, then you can see that this is bound to the H1 element up at the top here. And you can do some cool things with this and mess around with websites. Like if you say $0, which is the H1 element, dot in HTML is equal to, instead of JavaScript, let's say it's equal to AngularScript. And now I've just edited Wikipedia's website on the fly, and this is a fun way that you can mess with friends. Now, of course, once you reload the website, then all of your changes are gone because it's loading up the HTML page from Wikipedia's servers. So all the changes that you're making is to your local copy of this Wikipedia page inside the browser. But if you catch your friend unaware and edit some of these pages, it's a pretty good prank. Now, at the moment, when I click on this H1, absolutely nothing happens because it's not a button and it's not bound to any event listeners, at least not yet. But that's exactly what we're going to do. We're going to say $0, referring to the H1, dot add event listener, and the type of event that we want it to listen to are clicks. So that's the first input. The second one is going to be a function, and that function is simply going to console log the fact that I got clicked. All right, cool. So now if I hit enter, then that click event listener gets added to our H1. And if I click on this, I now get the console log that says it got clicked. And I can do that many, many times. Now, in this case, we've got an anonymous function as the second input. And we know that we can also specify it like this. So instead of using an anonymous function, we could use a named function, say something called respond to click. So the word click is the event that we're detecting, and that's the first input, or input 1. Now, the second input is the function that should be called once the H1 detects the click event. So you can see that add event listener is taking 2 inputs. The first one specifying what event it should listen to, and the second one specifying what it should do once that event gets detected. Now, this is a little bit different from the functions that we've seen so far, because instead of just passing in strings or numbers or other simple data types, we're actually passing in a function as an input. Now, because we can't look at the code that Chrome uses to implement add event listener, because we didn't write that method. So let's try and create both sides of the coin, and in the process, we can better understand how add event listener works. So let's say that we wanted to create a calculator. So we could create a function that's called calculator, and it could take 2 inputs, the first number and the second number. And then we're going to do some calculations with it. So we'll say maybe return as the output, the first number plus the second number. So now if I call this function and I pass in some values, say 2 and 3, then I will get the output as 5, right? 2 plus 3. Now, if I wanted to change my calculator, so instead of adding my numbers, I want my calculator to be able to multiply, then I would have to change my calculator function and say, instead of adding, actually, I want my calculator to take these two numbers, first number, second number, and then it should return the first number multiplied by the second number. So now I can call my calculator and pass in the same input, 2 and 3, and I'll get back 6. Because now our calculator function is multiplying the first number by the second number. Now, this is a little bit painful because, the kind of calculators that we're used to allow us to specify on the fly whether if we want to multiply or add or divide. We don't actually have to go and change the actual calculator each time. So what can we do instead? Well, what if we created a function that was called add, and it took two inputs, the first number and the second number. And this function basically just adds the numbers, right? So it returns the first number plus the second number. And then we go and create another function. And we call this one multiply. And this one, again, takes two inputs. And it returns the first number multiplied by the second number. So now that we've got two different types of functions, how can we create a function that's called calculator to be able to pick and choose whether if we're going to add or multiply? So this is a case where being able to pass in a function as an input to another function becomes really handy. So say we've created this function called calculator, and instead of simply just taking two numbers as the input, it's also going to take an input called the operator. And this input can be changed on the fly when we're calling this function. And when this function calculator gets called, we simply call the operator function, whatever it is that the user chose, passing in the two inputs, and return that value as the output. All right, so now let's go and hit enter and have all three of these functions available to us. And let me show you how we would call this. So instead of having to say add 2 and 3 or multiply 2 and 3, we can simply call our calculator function and we can pass in our numbers, let's say 4 and 5. And the third input, as you can see here, is expecting a function because it's going to call it inside the body of this calculator. So let's say if we wanted to use our calculator to add 4 to 5, then we can simply specify the name of our add function that's created up here. And if we hit enter, you'll see that we get the result 9. Now, if we decided to use the multiply function instead, then what would happen is that we would call the calculator function. It would go and find where it was declared. 4 would get passed into the first input, num1, 5 becomes num2, and multiply becomes operator. So once it gets into the body of the function, it's going to output whichever function was passed in as the operator, so in this case, multiply, and it will pass into that function multiply the same two numbers that we passed into calculator. So now if I hit enter, you can see we get 20 because our calculator is using this function to calculate instead of this one. Now, before we mentioned that Chrome Developer Tools does a whole bunch of really awesome things. And one of those things is something called the debugger. So if you just type in the keyword debugger and then hold down shift and hit enter, then call the function that you want to debug, say calculator, 3 and 4, and multiply, and then we hit enter, then we enter the debug mode. So this is cool. And what you can do here is you can step through all of the steps that the browser goes through to give you that final answer. So we can see the process step by step. So this is usually used when you're trying to figure out what's going wrong in your code, because instead of playing computer in your head where you're imagining what should happen every step of the way, sometimes you're wrong, and it's really useful to see what's actually happening every single step of the way. So let's start. The first thing you're going to do is you're going to click on this button here with a down arrow, and this steps into the next function call. So once I click on it, we start off by calling the function calculator. So it goes and finds where that function was defined, which is here, of course, and it passes in those inputs that we gave before, which is 3, 4, and multiply. So now num1 equals 3, num2 equals 4, and the third input, operator, is equal to a function, as denoted by the little F sign, and the function is the multiply function, which is up here. So now the next step is that it enters into the body of the calculator function, and it tries to call this function operator, which is currently the same as the multiply function. So now if we keep stepping through, it finds that multiply function and it subs in those two inputs where num1 is equal to 3 and num2 is equal to 4, and it returns the value of num1 multiplied by num2. So now if we continue stepping through, it takes that value that we got back and returns it as the output of the multiply function, and then returns it as the output of the calculator function. And finally, we get to the end of our code and we output the number 12. So this is a pretty neat trick whenever you're getting confused what's actually happening in each of the functions you write. And this way you can see stepwise everything that the browser is doing one function call at a time. These types of functions, which can take other functions as inputs, are called higher order functions. And this feature is available in a number of modern languages like JavaScript, Haskell, Swift, and a whole bunch of other ones. But it's not universal. It's not something that's available in all programming languages. But it's something that we'll rely on heavily in JavaScript as we learn to manipulate the DOM and give our website more and more behavior. So we'll come across this many, many times. Now, as a challenge, I want you to create a full set of operators for our calculator. So I want you to create the code that we've already made. So a calculator that takes two inputs and a function as an input, and complete these functions so that we have an add function, we have a multiply, we have a divide, and a subtract, so that when you call the calculator, you can say something like calculator 6 and 3 and subtract, and it will give you the right answer. So pause the video and complete that challenge. And once you're done, go ahead and try out the debugger and step through the function calls so that you're happy with how it works and how you can pass functions as inputs to other functions. Now, in the last lesson, we figured out how we could add an event listener to all of our buttons. In this lesson, we're going to take it a step further, and instead of showing an alert, we're going to play the sound of a drum. So playing sound is super easy using JavaScript, but let's see if we can find out how to do it if we didn't know. So let's say something like play sound JavaScript. Let's see what we get. So the first result that we get back is a Stack Overflow post where somebody's asking how you can play audio using JavaScript. And the first answer says that you can do it by creating a new audio object by saying new audio, and you give it the name of the file that you want to play, and then you simply call the method play on your new audio object. So that seems pretty easy. Well, let's test it out. Inside our event listener, let's get rid of the alert and let's instead try to play our sound. Now notice that all of our sounds are located inside the sounds folder, so you'll have to specify the folder when you try to locate the sound that you're trying to play. So as a challenge, I want you to try and implement this code inside our function here, and I want you to play the tom1 drum that we've got here. So it's called tom-1.mp3. And if you do succeed, then pressing on each of these buttons no longer generates an alert, but instead plays the sound of the drum. So pause the video now and see if you can make that code work. All right, so let's move this code over here and see if we can figure out what it's trying to do. So the first thing it does is creates a new variable. And then it seems to create some sort of new audio object, and it specifies the name of the sound file. So in our case, our sound file is called tom1. So in order to navigate to it, we will have to say sounds, which is the folder that it's in, and then it's called tom-1.mp3. And then with this new object created, we're going to call play on it, which seems to be a method that will play the sound. So let's hit save and refresh our website and see if that worked. Cool, nice, right? Now that was pretty easy, but what exactly are we doing with this line of code? And very often when you're trying to do something, you will come across code snippets that helpful programmers have provided in Stack Overflow. But it's really important that if you're going to implement it in your own code, to find out what the code is doing and how it works. So let's do that now. Now, if we search in Google for new audio JavaScript, which is basically the part of the code that we used, where we created a new audio object, then you can see that the first thing that pops up is our ever so helpful MTN web docs, and it shows us what we're trying to create. By writing that line of code, we're essentially creating an HTML audio element. And you can see this is exactly the same syntax. So you're creating a variable that stores this new object by writing new audio, and then here you've got the URL or the location of that audio. And what this line of code will do behind the scenes is it will actually construct an HTML audio element. Now, this HTML media element that we create has a whole bunch of properties. So, for example, you can set the current time that you want to play, or you can see whether if it's been played or if it's paused. But it's also got a whole bunch of methods, so things that you can make that object do. And that includes the play method, which basically plays back our media. Now, at the moment, no matter which button we press, we always get the same sound, which is, of course, the tom1 drum that we specified here. But if you take a look inside our images, we've got all of these different images of different drums that we can play. And each of the images correspond to a different sound sample that corresponds to those images. So let's go ahead and assign each of these buttons a background image using our CSS. So here's a challenge for you. I want you to take a look inside the style.css and assign a background image to each of these buttons. Now you can order your buttons in whichever way you like. So if you want the tom drums to begin with, then you might do tom 1 through 4, or you might begin with the snare and end with the kick drum. It's completely up to you. But by the end of this, each button should have a background image that's going to give the user a hint as to which sound it will make. So you might need to take a look at the documentation or Stack Overflow in order to figure out how to do this. But pause the video now and see if you can complete this challenge. Now I've decided to have the 4 tom drums, so tom 1, 2, 3, 4, for the first 4 buttons, and the last 3 to be the snare, the crash, and the kick drum. So remember, we're now writing CSS. And the property that we want to tap into is the background image. And we're going to set it to a image URL. So this is going to be the source or the location of our image, which is going to be a string that's images. So that's the folder that contains the image. And then we're going to start off at tom1.png. And now if we hit save and refresh, then you can see we've assigned an image to the background of our first button. I've gone through this to assign the images in the order that I want it to show up. Now, if you created this in a different order from me, then that's completely fine. But just remember to check back at your images to remember which one is at which button so that you can assign the correct sounds. So now we have to solve the next problem, which is how do we get each of these buttons to play the sound of the corresponding drum image? Well, if you think back to our lessons in the introduction to the DOM modules, we know that we can grab the inner HTML or the text content of any of these buttons. And you can see that they all have a different character associated with each drum. So what if we use that to differentiate the buttons so that when a user presses on a button, we get the character that the button contains, and then we use that to determine which sound we're going to play them. So that seems easy enough. So I'm going to put our sound code down at the bottom and I'm going to comment it out so that we can focus on one thing at a time without this code distracting us. So now we need this function to be called when a button detects a click, and we need to know which button got clicked so that we can play the right sound. So essentially, we just need to know which button triggered the event. So at the moment, we've attached a listener to our button, and when the user clicks on the button, the listener gets triggered, and the function that was linked to the event listener gets called. Now, we can figure out the identity of the button that triggered the event by tapping into something called this. And this is basically the identity of the button that triggered the event listener. So let me show this to you by logging it in the console. So let's console log this and let's refresh our website. So now if I click on one of these buttons, you can see I'm actually getting the button object that triggered the event by simply console logging this. And I can do this with all of the different buttons. And now if I have access to this object, then I can use properties such as inner HTML, which we've seen before. So now it will print out the inner HTML of the button that triggered the click event every single time I click on a new button. Now there's quite a few lines of code that we've just written, so let's break it down so we can understand what's going on. So inside the loop, the first thing that we do is we look through the document and we try to grab all of the elements that have a class of drum. So that basically gets us all of those buttons that have that class of drum. Now the next thing we do is we loop through all of those elements, starting from when I is equal to 0, and we add an event listener to it. And the next time we loop through, then I becomes 1, and now we add the event listener to the second button. So essentially, our code will go through all of the buttons in turn, selecting them and adding the event listener until we've gotten to the end of all of our buttons. So now that all of our buttons have an event listener attached to it, what happens when we click on the first button? Then that button's event listener will trigger the function that was attached to the event listener. And in this case, that's simply to just console log this, which is simply the button that triggered the event. Now, we're not simply limited to console logging the identity of the button. We can also use its identity to change its style. So as a challenge, can you see how you can modify this code to change the text color of the button that got clicked to the color white? Pause the video and see if you can complete this challenge. So if we already know the identity of the button that got clicked, then we can simply say this.style.color equals white. And instead of console logging it, we're just going to run this line of code. So now if I refresh the website with that new code, then you can see that whenever I click on a button, I change the text color to white because we're able to get the identity of the button that triggered the event, and we can change its style and color to white. So up till now, you would have heard me talk about objects and using the object's properties or methods. But let's really truly dig in and understand exactly what JavaScript objects are and how we can use them to dominate the web. Now, let's say that you've just inherited a hotel and you're in charge of running it. Now, when you arrive, the first thing you notice is that there's a whole load of bags that are in the lobby, and you've got guests who are checking in and leaving their luggage. So, what do you need? You need a bellboy, right? So, let's go ahead and employ our first bellboy. His name is Timmy. Now, in addition to his name, there's a number of other things that you need to know from your bellboy. So, let's quiz him. All right, Timmy, you can drop the suitcase now. What is your name? My name is Timmy. So we could create a variable to capture this data, and we could call it bellboy1name. Now, as we keep quizzing him, say, what is your age? Do you have a work permit? What languages do you speak? We can start capturing and saving all of this data by creating a whole bunch of variables. So that means if we were to instruct our bellboy to greet a guest, then we could write our line of code like this: alert, hello, my name is, plus bellboy1name. So this would create a pop-up saying, hello, my name is Timmy. So up till now, we should be very familiar with this kind of syntax. But let's say that we're really good at running hotels and it gets completely booked out, and we're effectively swamped with guests and luggage. Now, Timmy can't manage by himself, so let's employ some other bellboys, bellboy 2 and bellboy 3. Now, if we were to go through this process of creating var bellboy 2 name equals Jimmy, etc., it will take forever. So what can we do instead? Well, in real life, this information might be better represented by a table or an Excel spreadsheet like this. Because we need to know the same properties for each of the bellboys, we can simply just create a number of rows that represent each of the properties, and as we recruit new bellboys, we just fill in the values of each and every property. Now in JavaScript, we could create something really similar to this by simply creating an object. So we would create a variable that's called bellboy1, and it would have a number of properties that we will assign values. And all of these properties are enclosed inside a set of curly braces. Now, inside here, we could simply say name is Timmy, age is 19, has work permit is true, languages are this array of languages. Now that alert might look like this. So hello, my name is, plus bellboy1, which is the name of the object, dot name. And we're using the dot to access the property that's called name. And this would create an alert that says, hello, my name is Timmy. But our data is now far more structured, and it's much less likely that we'll make an error when we're assigning names and ages to our new bellboys. And by doing this, we've effectively just created a JavaScript object. Now, if we were to create a housekeeper object, then the properties that we define probably will be quite different. We might be interested in things like how long have you worked as a housekeeper, which other hotels have you worked at, or which kind of cleaning tasks are you happy to do. So for different objects, we will create different properties depending on what is relevant to that object. So I want you to have a go at creating objects. So head over to the Sources tab inside the Chrome Developer Tools, and I want you to create a new object that is housekeeper1, and she needs to have a number of properties. So depending on what you think might be relevant properties for a housekeeper, then go ahead and just add those to that object. So pause the video now and see if you can complete this challenge. All right, so we're creating a new object, and we do that the same way that we create new variables. We start off with the keyword var, and then we give our object a name. So in our case, we're just calling ours housekeeper1. And then we're going to set it to equal. But instead of just giving it a value, as we've done before, we're going to give it a number of properties. And all of those properties are enclosed inside a set of curly braces. Now, the first property the housekeeper might have is, say, years of experience. And she's got 12 years of experience. So the left-hand side is the name of the property, and you can name it whatever it is that you want. And a good idea is to follow the rules of convention of naming JavaScript variables. So all of those things about camel casing, as well as not using numbers to begin with, apply here as well. Effectively, when we're creating properties inside objects, we're just creating a variable that's associated with another variable. And of course, you can assign it any value you wish, a number, a string, an array, whatever it is that you want. So let's say our housekeeper has years of experience and has a name. Let's call her Jane. Then she could have an array called cleaning repertoire. And this could be an array that has things like she's happy cleaning the bathroom, she's happy cleaning the lobby, and she's happy cleaning the bedrooms. All right, cool. So now we have this new object called housekeeper1, and we've got a number of properties that we've filled in. So if we go ahead and hit Command Enter or Control Enter, or simply press on this button, then we've created this object. And we can tap into it by simply saying housekeeper1, and we get access to all of these properties. And we can tap into the properties by simply using the dot notation. So for example, we can say console.log housekeeper1.name. And this will give us Jane, because that's the piece of information that we've associated with the property name inside our object housekeeper1. Now, let's say that our hotel has just been featured in the top hotels in the world, and we're literally full every single day. And we actually need far more bellboys than just the 3 that we've already got. And going through this process of every single time when we have to create a new object, we have to write the name property, name value, age property, age value, and actually, if you notice, for all of our bellboys, we have the same properties, and we don't actually have to type out all of these properties again and again and again every single time we want to construct a new bellboy object. So what's the solution to this? Well, we can actually create a factory that basically just pumps out bellboys all day long. That factory in JavaScript code would look something like this. So we would create a function that has the name of bellboy. And this is called a constructor function. And what's special about constructor functions is that the names have to be capitalized, and it's no longer the same camel casing that we've seen so far. The first letter of the first word also has to be capitalized. And this is how we can tell that this is a constructor function and not just any odd function. Now, the constructor function takes a number of inputs, and these are the inputs that we're going to provide when we create new objects from this constructor function or from this factory. And inside the constructor function, we match the inputs to property names. So for example, we will say this object dot name is equal to the name that was given as an input when we constructed this object. Now, this looks a little bit confusing, but let me show you what it looks like when we initialize a new object, or effectively when we create an object from that factory. So we would write something like var bellboy1 is equal to new bellboy, notice the capital B, parentheses, and inside the parentheses, we would provide the inputs to all of those properties. So the first one was the name, the second one was the age, the third one was whether if they had a permit, and the fourth one was which languages they spoke. So this is much, much shorter than our previous version, where we had to specify the name of the property every single time we created a new object. And we can use this factory or constructor function to create new bellboy objects all day long. And effectively, the only difference between this syntax and calling a normal function is the keyword new and the fact that the name of the function is capitalized from the beginning. So now it's your turn. As a challenge, I want you to take what we did before, where we created a new housekeeper1 object, and I want you to create a constructor function for it. So instead of creating it like this, I want you to use what you just learned and create the constructor function for any housekeeper objects. And then to create the object housekeeper1 using that constructor function. So pause the video now and give that a go. So the first thing I'm going to do is I'm going to empty cache and hard reload so that our housekeeper1 object no longer exists. Now I'm going to reformat this code. So instead of having to write this out every single time we create a new housekeeper object, we have to say housekeeper2, years of experience is 3, etc., etc. We're going to now have a factory that just creates housekeeper objects. So to begin with, we need to create a function, and the function name has to be capitalized. So we're creating housekeeper objects. Now this function is going to take a number of inputs, and those inputs correspond to all of the properties we need. So the first one is years of experience, second one is name, and the third one is cleaning repertoire. And now inside the function, we're going to give it some properties. So we're going to say this object is going to have a years of experience property, and it's going to be equal to the input that comes in through here. And then I'm just going to go through this and create this code for all the other properties. All right, so now that we've created our constructor function, I'm going to delete where we created the first housekeeper object, and I'm going to run this code. So now inside our console, we're going to create a new housekeeper object. And instead of going through this long-winded approach of specifying the name of the property, the value of the property every single time we create a new object, we're simply going to say var housekeeper1 is equal to new. That new keyword is really important because we're going to be using a constructor function afterwards. New housekeeper, notice the capitalized H, and then inside the parentheses, we're going to provide the values of all three properties. So years of experience, let's say 9, and then name, let's say he's called Tom, and cleaning repertoire, let's say he's only good for cleaning the lobby and bedrooms. So now if I hit enter, and I console log our new housekeeper1's name, then you can see I get Tom. So our object has been created. So now that we've created this constructor function, every single time we want to create a new object from it, it's as simple as just filling in the properties with the new values. And we can use that object factory to pump out new objects with those same properties all day long. So now that we know which key was pressed, and how we can get its inner HTML, how can we play a different sound depending on which key was pressed? Well, you might think to the if-else statements that we learned in our introduction to JavaScript modules. But there's actually 7 keys in total, so we would have to write quite a few if-else statements. Now, in this scenario, it would actually be easier to write what's called a switch statement, which, just like a railroad switch, it will take the code down a different track depending on the value of a variable. So let's delete this line of code and let's start writing our switch statements. Now inside Atom, as soon as you start writing the word switch, then our autosuggest will helpfully give you the skeleton of a JavaScript switch statement. So if you hit enter, then it'll give you the bare bones of what it should look like. So you can see the keyword here, instead of if, is switch. And then afterwards, we have a set of parentheses, which includes the expression or the thing that we're going to switch on. And in our case, we're going to switch on the letter that is inside the inner HTML of each of these buttons. So let's create a variable that holds that value. So we'll call it button inner HTML, and we'll set it to equal this. So remember, that's the button that triggered the event, dot inner HTML. So now let's switch the button's inner HTML, and depending on the case, we'll tell it to do something different. So the first case is if that was equal to W. So remember, our first button has an inner HTML of the letter W. So if it was the letter W, then we're going to tell it to play the Tom1 drum. So I'm going to take that code that I commented out and then put it in here so that it will play the first drum. Now, after the first case is done, then there is a break statement, which tells the code to exit the switch statement and continue with the rest of the code. Now, if button HTML didn't happen to be equal to W, then it could be equal to something else. So in that case, we would have to specify the next likely scenario, which is what if the inner HTML was A, i.e. the second button got clicked? Well, in this case, we're going to play the next sound instead, and we're going to play the tom2.mp3. And once again, we have to end our case with a break. So the switch statement looks a little bit weird because instead of having, say, for example, an open parentheses here and a closing parentheses here, it actually has a colon and a break keyword instead. But just know that it's basically the same thing. Between the colon and the break keyword are all the things we want the website to carry out if the button inner HTML was equal to this particular case. Both are, now in this case, instead of calling both of our sounds audio, we should really give it a different name. So why don't we call our first one the sound that it's going to make, so tom1, and our second one tom2, after the sound file that's going to be played. And remember, if you're going to change it here, then you have to change it here as well, so that you know that you're playing tom1 and you're playing tom2. Now I've just gone in and added all of the remaining cases for the key S, D, J, K, and L. So now I've gone in and I've added all of the other remaining cases so that our website knows what to do if the S key was pressed or the D or the J, K, L. Now the final case that we've got is actually the default case. Now the default is kind of like the else statement at the end of an if. It covers all of the other scenarios that we haven't specified. What if the button inner HTML wasn't WASD and instead it was something like 1 or comma? Well, that's when the default will trigger. Now, even though in most cases the default will likely never be triggered, it's still good practice to include it, as you can't always predict ahead of time what might go wrong in the future, right? And the value could always be something that you didn't expect. So let's just go ahead and add a console log that logs the button inner HTML that triggered the default case. So let's hit save, refresh our website, and you can see now if I click on any of these buttons, you can see that we get a different sound for each button click. That's pretty cool, right? Now in the next lesson, we're going to dig into keyboard events and see how we can use the keyboard to trigger these sounds instead of having to press on the buttons. So for all of that and more, I'll see you on the next lesson. Now, what about methods? Let's say that our bellboy is able to do something called move suitcase. Now, I've kind of simplified it here, but it's effectively, he creates an alert saying, may I take your suitcase? And then he picks up the suitcase and then he moves with the suitcase. Now, this is a function because at the moment it's not attached to an object. But in our previous syntax, if we wanted our object to also have an associated function, then all we have to do is provide the name of the function as a new parameter, and then colon, and then after the colon, we just put in the anonymous function. And now our bellboy1 has a method, which remember is just a function that's associated with an object. And if we had a suitcase in the lobby, then we can simply call the method and say bellboy1.moveSuitcase and perform that method. So remember that when we're using the properties or calling a method, we're always using the dot notation. And the only difference that you see between the method and the property are those parentheses. So keep an eye out for those. Now, if we wanted to incorporate this method into our constructor function, then all we have to write is this .moveSuitcase is equal to a function that does these and these things. And now when we create any object using this constructor function, then all of those objects will have that function of moveSuitcase, and they'll all be able to do that. So as a challenge, I want you to add a method to our housekeeper constructor function. And this method is just called clean, so that we can get the housekeeper to perform the clean function. And we're going to do it in a simplified way so that our method, all that it does is sends an alert that says cleaning in progress. So add that to the constructor function, create a new housekeeper from that constructor function, and call the cleaning method associated with that new object. So pause the video now and see if you can complete this challenge. All right, so as we said before, to create a new method or a new property, we first have to start with this, the name of the property or method. So our method is called clean, and it's not equal to just any value, but it's equal to a function. And this function, as we said before, has to send an alert that says cleaning in progress. So now that we've got our method associated with our housekeeper constructor function, then we need to create new objects that have this method. So let's go ahead and again empty cache and hard reload, and let's run our new code, and then let's create a new object called housekeeper1, which is equal to a new housekeeper which has 12 years experience. He's called James, and he's only qualified to clean bedrooms. All right, so now let's hit enter and create our new object called housekeeper1. Now housekeeper1 now comes equipped with this method called clean. So we can simply say housekeeper1 dot clean. And if we hit enter, you can see that we get an alert that says cleaning in progress. Pretty good, right? Now, at this point, you might be getting a little bit of deja vu because it's looking pretty similar to something that we've written before. It looks almost exactly the same as these lines of code that we used to create a new audio and to play the audio. Because we created a new variable that was called tom1, and it's a new audio object that is linked to this particular sound file. And then later on, we use that object method called play to play that sound. So even though we can't see the source code of this constructor function, but we could guess at what it might look like. So the constructor function for this audio object might look something like this. So as with all constructor functions, you start off with the keyword function, and then you have the name of the object that it's going to construct with the first letter capitalized. And then in between some parentheses, we have some inputs. And in this case, it's going to be the location of the file for that audio. So now our constructor makes a new property called file location, which is set to equal to the location that was given when this new audio object gets created. And then this constructor function also has an associated method called play. And this play function does a number of things. For example, it might tap into the audio hardware of the computer. It might check whether the file at the file location specified exists. It might check that the file is actually a sound file. And then it might try and play that file at that location. And all we had to do was to use that constructor audio to create a new audio object specifying the location of our audio file. Then we simply called the method that was associated with that new audio object and got it to play that sound. Now, a lot of the code that you'll be writing in JavaScript involves using these properties and methods associated with the objects on your website. And occasionally you'll also need to create your own objects in order to get some custom behavior on your website. Now, hopefully this lesson has helped you to understand what we've been writing when we created our audio objects and when we called our methods or when we used our properties in our DrumKit website. Now, a lot of these concepts are quite abstract, and it might take a little bit of repetition and coming back to it a few times in order for it to start making more sense. But as with all things programming, as we get more practice using a lot of these concepts, over time, it will become more and more familiar to you, and the puzzle pieces will start coming together. So don't worry if some of this stuff is going over your head. We're going to be revisiting this in the future as we keep building more and more websites. But this is a great place to just sow the seeds about objects in JavaScript. And hopefully you'll revisit this lesson a few more times and eventually getting really comfortable with this concept. Now, if we wanted our website to not just detect button presses, but also to detect keyboard key presses, to activate the relevant drum. Say if I press the W key, then it should activate this drum, and if I press J, then it should activate the snare. Then how exactly do we do that? Now, instead of adding an event listener to listen for clicks, we can listen to a key press event instead. So we would write something like add event listener key press, and notice that the weird thing about events is that they're named all in lowercase. And it's a good idea to take a look at the docs whenever you're trying to type them, because it's pretty counterintuitive. So we're going to try and target this key press event. And if there was a key press, then we'll simply call an anonymous function which sends an alert that says key was pressed. So, but the problem is, what exactly do we add this event listener to, right? Because previously we added our event listener to all of the buttons so that when the buttons get pressed, then the event listener gets triggered. But in this case, we're kind of waiting for the keyboard keys. So how do we add an event listener to the keyboard? Well, you don't have to. You can add an event listener to the entire document so that the entire web page starts listening for keyboard strokes. So now let's hit save and let's refresh our page. And if I tap on any of the keys on my keyboard, then I get the alert that says key was pressed. Now the next problem is, how do we figure out which key was pressed exactly? Now remember how we said that when we add an event listener to an element, then once the event happens, the element will trigger the function that's in the second parameter. So in this case, when a key press is detected, it will trigger the function that tells the browser to show an alert. Now, when that function gets triggered, there's also the option to pass in a parameter. And we can call that parameter event or E, but essentially what it allows us to do is it lets us tap into the event that triggered the event listener. So instead of showing an alert, let's console log this event and see what we get back. So now if we refresh our page and we press any key, then you can see that what's logged in here are the keyboard events that triggered the event listener. So if you expand this, you can see that it actually gives you a whole bunch of information, including the key that was pressed to trigger the event, other things such as the key code, the character code, and a whole bunch of other things. So you can see that whenever I press any key on the keyboard, this event tells me which key was pressed. And that's kind of what we need in order to get our drum kit going, right? And if you look in the docs for the key press events, then you can see that they have a whole bunch of properties that we saw in the Chrome developer tools. And you can read about what each of them do by taking a look at the MDN docs. Now, the key that we're most interested in is this one called key. And this is the key value represented by the event. So which key on the keyboard got tapped, essentially. And this is what we need in order to figure out which sound to play. So notice how we already have this switch statement, which checks to see which key was passed in and responds by playing the relevant sound. Now the problem is that this is all inside the event listener for our button clicks. So as a challenge, I want you to create a function that takes a character and checks it against the switch statement in order to play the correct sound. And then we're going to call it inside the event listener for the key press, as well as the event listener for our drum buttons. So pause the video and see if you can complete this challenge. All right, so the first thing we're going to do is we're going to create this brand new function. And I'm simply going to call it make sound. And it's going to take a single parameter, which is going to be the key. Now inside this function, I'm going to relocate our switch statement. So I'm just going to cut it, and then I'm going to paste it inside my function, make sound. Instead of switching on the button inner HTML, I'm going to switch on this key. And I'm going to pass in that key by calling make sound, passing in the button inner HTML, which is essentially the inner HTML of the button that got pressed. But I'm also going to do the same thing down here. So I'm going to get rid of the console log, and instead we're going to call make sound, and I'm going to use the event.key. So now I have one section of my code, which is all about detecting button press. And then I have another part of my code, which is all about detecting keyboard press. And if a button was pressed, and then I check the inner HTML of the button that got pressed and send that to make sound in order to play the relevant sound. And if a key press was detected instead, then I send the event.key, so the key property of the event. So say if I press on the W button, then it's make sound W. And if I press on the W key on the keyboard, it's also make sound W. And they end up in here where we switch based on that key parameter. And then we play the relevant sound depending on which key was passed in. So let's save this and see if it works. So first I'm going to check by clicking on my buttons. Seems to work. And now I'm going to try and type in the characters. Awesome, right? So in this lesson, we learned about how you can add event listeners to detect keyboard strokes. And we used the same method, add event listener, but we added it to the entire document instead of a specific button or a specific element. And once that was detected, then this function gets called, passing in the event that triggered the key press. And that event contains a property called key, which tells us which keyboard key was pressed. And then we send that over to our function makeSound in order to make the sound that we want for that key. Now, in order to fully understand this part of the code, we have to understand how in JavaScript we can pass functions as parameters. And we can also have functions as callbacks, which include things that we get back after the event has happened. So in the next lesson, we're going to explore some of those concepts in more detail so that we can really get to grips with what exactly it is that we're writing here. So for all of that and more, I'll see you on the next lesson. Now, in previous lessons, we saw how JavaScript allows us to create higher order functions. When we talk about higher order functions, we're referring to the function that's able to take functions as inputs. So in this case, the add event listener is our higher order function, as it takes the respond to key function as an input. Now, what about the other side? What about the function that gets passed in as an input? Well, this is actually called a callback function because it allows us to wait for something to finish happening, for example, waiting for a click event, and then the callback function gets called back and executed. So previously, when our button detects a click, it calls the callback function. And in this case, when the document or the entire web page detects a key press, then the document will call this function respond to key. Now, when that happens, we can get it to send us some information that it'll only know once the event happens, namely, say, which button was clicked or which keyboard key was pressed. So if we head into our Wikipedia page again and we inspect on our JavaScript object, and we again gain access to the H1 using the $0 sign. Now, we know that we can add an event listener by simply saying $0, add event listener, say click, and once that does happen, let's call this anonymous function, and we can console log something. Now, in this case, all that we're doing is saying that attach this event listener to $0, which of course is this H1, and get it to listen for click events. When it detects those click events, get it to call this function. Now, this is a very simple form of the event listener, but as we saw in the last lesson, we can also get the event that triggered this function passed back through the callback function. So instead of console logging simply I got clicked, we can actually console log the actual event that triggered the function. So in this case, if I hit enter and I click on this JavaScript H1, then you can see that it's console logging the event that triggered the click. So in this case, it was a mouse click, and you can see all of these properties that are associated with that mouse event. For example, which part of the screen did I click on? what was the type of event, and a whole bunch of other things. Now, when you're creating this anonymous function, you can call this parameter anything you want. You'll commonly see it as E or EVT for event, and it'll work exactly the same. Now, the reason for this is because, say if we create a function called say hi, and we give the name of the input as 2, and then we say console log hello plus whatever input we got. So now we can call this function saying say hi to Tom, and it'll say hello Tom. Now we can also create a function, say hi, and instead of calling our input 2, we call it name. So now we're saying hi to name, and again, it does exactly the same thing, which says hello to the input that we pass in, which is name. So now we can again say hi Tom, and it'll still say hello Tom. So the name that you give the input really doesn't matter. It's the same as when you create a variable called name, or you create a variable called 2. It's completely up to you what you call it. So this is why when we create an event listener and we give that input any name, say E, it will still work exactly the same, passing in the event that triggered the callback function. But the slightly crazy part is that this callback function is not called by us, but it's called by the object that experienced the click. And when that happens, we can get it to send us some information that it'll only know once the event happens. For example, in our drum kit, then that's which button got clicked by the user. So this callback function can be a little bit confusing and a little bit mysterious. So again, as before, I want to show you both sides of the coin. So let's pretend to create the function add event listener, but so that it's not confusing, we'll call it another add event listener. And as we know, it takes 2 inputs, the first being the type of event, and the second being the callback. So this add event listener will do a number of complex things that detects when an event happens. But when an event does happen, then it'll create an event object. And let's call that object event that happened, just so that we're clear. So let's say that we pressed a key on the keyboard. Then the event object that gets created will capture a number of things about that event. For example, what was the event type? In this case, it was a key press event. And it might have another property, such as, well, which key then? Let's say that we press the P key to generate this event. And it might have other things like duration of key press. And let's say this was equal to 2 seconds. So when the event happens, namely pressing a key on the keyboard, then this object gets created based on that event. And now we can pass that object back through the callback method so that the programmer, if they wish, they can get the event object and use it to see what event triggered this event listener. But of course, we know that our callback doesn't get called for all types of events, right? So in fact, our add event listener might check to see if event that happened dot event type is actually equal to the type of event that the programmer was looking to detect. And then, and only then, do we actually trigger the callback function. So if this is our function, add event listener, and this is the part that we can't really see, then the part that we do see and the part that we write is actually just calling the add event listener. And we pass in a number of inputs, right? Say we're passing that we're looking to detect the key press event. And when that happens, we want it to trigger an anonymous function that essentially just does some console logging. So console log. And what we want to log is the event that triggered the callback. So now, if I hit enter, then you can see that when the event gets triggered by, say, a key press on the keyboard, and if the type of event was equal to the type that we were looking for, namely key press, then we trigger the callback. And the callback can send us that event object, which now gets logged in our console. So you can see this output looks really similar. Say if we were simply using proper code, not our simplified code, and we said document add event listener to listen for key press, and once you do detect that key press, then call the anonymous function, passing in the event that triggered the key press, and then we're simply just going to console log that event object. So now when I hit enter and I press any key on the keyboard, then you can see we get back this object called keyboard event, and it has a number of properties, including things like, for example, the key that was pressed to trigger this event. So again, I find that it usually helps to understand what exactly is going on here by using the debugger and stepping through each step of the way. So let's try this again, but this time we're going to use the debugger to see what's happening. So again, I'm going to call another add event listener, passing in the type of event that we're looking to detect, and also the callback that should happen when it does get detected. But just above, I'm also going to add the debugger keyword so that when I hit enter, I enter the debug mode. So now I'm going to step through our function calls, and we begin by calling add another event listener, passing in these two inputs. So that takes us to where that function was declared, and we step through each of the lines of code. The first thing that happens is we're waiting to detect an event, and this part of the code waits to detect an event. Let's say that in this imaginary world, I press the P key on the keyboard. Now at that point, then this event that happened object gets created, and it captures a lot of information about my key press, namely that the event type was of the key press type, the key that I pressed was P, and I pressed on it for 2 seconds. So now that we have this event object created after I triggered the event, then our code will check if the type of the event that happened is equal to the type that the program was looking for. Then it will go ahead and trigger the callback function. And if we step through, then you can see that the callback function is, of course, this part, the function that we used as an input. And it goes ahead and tries to log the event object. And this is when we see that event show up down here. And that is how we came about getting hold of this event object. Now, callbacks are notoriously difficult concepts to grasp, and even some developers who've been working for a number of years struggle with this particular concept. So don't worry if this is the first time you've come across it and it seems a little bit confusing. What I encourage you to do is to recreate our add event listener function and just go through the motions of what I did in this lesson without having to watch the video. Play around with the code and also play around with the debugger and see how the code works behind the scenes. Now, we're going to come back to this topic of callbacks many more times in the coming lessons. So this is not the only time that you'll come across it. And for all the difficult concepts, I try to sprinkle in plenty of repetition so that I make sure that you really do get it, because it is a really important concept that we'll come to rely on when we're creating more and more complex web apps. Now, wouldn't it be nice to see the buttons flash when we click it or press the key that corresponds to it? That way, the user will know that they pressed the right key and they're getting the right sounds. Now, given that we want this animation to happen both when the button gets pressed as well as when a keyboard key gets pressed, then we probably would want to create a function, right? So let's create this new function called button animation. And we're going to need a parameter to be passed in, which is the current key. And we can call this function in both places where we call make sound. So in this case, we've added an event listener to all 8 drum buttons, and then when one of them gets clicked, then it carries out this function. And inside this function, not only do we want to make sound using the current key, but we also want to generate the button animation. So let's call our method up here, and it's of course called button animation, and we're going to pass in the key of the button that was triggered. So that's going to be the same as our button inner HTML. So it's going to be exactly the same as before. So we're just going to add button inner HTML. Now in the case of our keyboard key press, we're also going to call that method button animation. And in this case, we're going to pass in the event key. So now in both cases, we're passing in exactly the same parameter. And that is going to be a single character corresponding to the key or the button that was pressed. So now that we have that value inside here, we can use it to generate the animation. So remember that in our index.html, we have 7 buttons which all have these classes assigned to them. And all 7 of them have the class drum. But they each have a different class depending on what's the letter inside the button. So we can use this in order to query our document for that selector. So we can say query selector, say .w. So that's going to be the element that has a class of w. Then we get back our w drum, this one here. And we can do the same thing with any of the other ones. Say k, then we get the k drum over here. Now notice that when we use query selector, we have to say dot and then the name of the class. It's just the same as in our CSS. So over here, if we want to query our document that has the class of the current key, then we have to write document.querySelector and we can add the current key. But the current key is just a single character and we need to concatenate a full stop in addition to the current key, so that we get the same format as we've got here, .w or .k. So now that we've found the button that has the current key, let's assign this to a variable called active button. Now, this is the button that we're going to change its style, and the style that we want to apply has already been defined in our style.css. So in here, I've already created a class called pressed. And pressed basically applies a shadow and also a transparency to whatever element that we add this class to. So I want you to try and think back to the lessons where we spoke about of how we can add a class to an element using JavaScript. And you might have to think back a few lessons, but try and see if you can complete this challenge by adding the pressed class to the active button. So as always, it's good to test out your code inside the console. So let's just select the H1 by saying document.querySelector, H1, and we're going to tap into its class list. And remember, this is the list of classes that it has applied to it, which currently is nil. Now, once we've gotten the class list, we can add new classes. For example, this pressed class. And if I hit enter now, you can see that shadow and that transparency gets applied to our H1. Now this is exactly what we want to happen, but to the button that got pressed. So we know the element that we want to apply it to. It's the active button. And all we have to do is just to tap into its class list and add the class of pressed. So now let's refresh our page. And you can see that when I click on any of the buttons, that transparency and the shadow gets applied to the button. Now there's just one problem. This doesn't come back. We kind of want it to have this depressed mode and then come back to the original so it looks like it's an animation. But in this case, I can't generate that effect ever again if I've clicked on one button. So how can we do that? Well, in order to do this, we need this line of code to be run. And then after a delay of, say, 0.1 second, we want this class to be removed again so we get back to the original look. So how can we do this using JavaScript? Well, let's see what we can find online. So we're looking for a timeout function in JavaScript. And the first result we get back is from W3 Schools. And it's a method called setTimeout. And you can see that in their demo code, that when you run this line of code, that it will wait 3 seconds and then it'll generate an alert that says hello. So this is exactly what we want. So let's look at how this method is structured. You can see that this is the syntax, and the first parameter is the function. So this is the function that will be executed after a certain amount of time. And the second parameter is how much time to wait before running this function. So let's try it out in our code. So we're going to write set timeout, and the first parameter is going to be the function that we want to be executed. So we're going to use an anonymous function, just as we have done before, and we're going to specify what we want to happen. So in this case, we want our active buttons class list to remove that pressed class so that it goes back to the original state. And the second parameter is the amount of time that we're going to wait before we run this function. So I think through some testing, it seems like 0.1 second seems to work best. So now we've got our active button that is found based on the current key that got pressed, and then we add the pressed class to give it that style of the shadow and the transparency. And then finally, after a wait of about 0.1 seconds, then we remove that class from the class list. So let's see what this looks like in action. Pretty neat, right? And if all goes well, it should also work for our key press event, because when the key press is detected, then this function gets called, and we can tap into the event that triggered the key press by using event.key, which then gets passed into our method called button animation, and it will do exactly the same thing as it did for the button. That looks pretty cool, right? So I hope you had fun in this module building your very own drum kit website, and in the process learning more about the document object model and some of the more advanced parts of JavaScript. Now in the next module we're going to jump even deeper, and we're going to learn about a popular JavaScript framework called jQuery. So for all of that and more fun projects, I'll see you on the next module. Hey, it's Angela again, and I'm here to congratulate you on coming really far in the course. Not everybody gets to see these videos that you are watching, and just in terms of your perseverance and the level of dedication that you have to be able to reach here is fantastic, and it really sets you apart from other people. So congratulations, you deserve a pat on the back. Now, I also want to talk about something that I've heard a lot of students say when they reach around this kind of time point, where they say like, oh, you know, even though I've been going on and learning for so long, I've done like 100 days, 1 hour a day, and I still feel like I don't know anything, or I don't know everything. And firstly, nobody knows everything. Even if you just take something as simple as like one particular technology, there's too many things to know. You only learn the things that are relevant to what it is that you're trying to achieve. Now, aside from the fundamental skills, of course. So the thing that I tend to tell students is you've actually made huge leaps in terms of where you were before. But it's just that as you keep getting, more advanced, and there's more advanced topics coming up around you, your level of struggle seems to be kind of constant, right? It doesn't ever really get easier. And I can testify to that. Like, even at my level, there are still loads of things that really are mind-boggling. And I sit there thinking like, oh, I wish I was smart and I could just understand this immediately. But this is just, it's fantasy. We all have to work hard in order to get what we actually end up with, our results. So what I want you to do, whenever you feel like I've done so much work and yet I don't feel like I know everything yet, is to go to the early parts of the course, have a look at the questions that the students who are just starting out, maybe in the first, second, third modules, see what questions they're asking and see how easy it is for you to answer those questions. Because of where you are now, those struggles that they have,
and you probably had at one point as well, are so much easier for you to be able to understand. And you can see at a glance, like, oh yeah, that's totally because of this or because of that. And just by, answering some of these student questions, the people who are at an earlier stage, you'll actually feel like you've gone further and, you have achieved a lot since when you first started. So try it out, let me know how it goes, and I hope that you will keep going and that you will achieve your potential. So